Problem 11, evaluate the integral of e to the negative x over e to the negative x plus 2 quantity cubed. Right, I know in this one, if we have more than one e in a problem, we'll let u equal a chunk. And the chunk we'll let it equal is what's inside of the parentheses, so I'll let u equal e to the negative x plus 2. So du, the derivative of e to the negative x plus 2 will be negative e to the negative x dx. And I notice I have that, I'm just missing a negative, so negative goes on the inside and the outside, so I now have negative. Everything turned into du, and then on the bottom I have u cubed. So if I rewrite that, I'll have u to the negative 3 du, and then I'm going to bring my negative down. The adding 1 to my power for this would be u to the negative 2, and then times negative 1/2 on the outside, and that will turn into 1/2 u to the negative 2. Then I'll bring my u down to the bottom, so I'll have 2 u squared, so it'll be e to the negative x plus 2 squared plus c, of course. Right, number 12. Find the derivative y equals x to the 4 times 4 to the x. All right, on this problem we do have multiplication going on, so I do have to use the product rule. So I'm going to label this f and g. F prime will equal 4x to the third. And then for this next part, if you have 4 to the x, which is actually equivalent to a to the u, if you recall, the derivative of this will be a to the u times ln a times du. So that's the formula I'm going to use. So when I go to find g prime, I will do a to the u, which is just 4 to the x, times the natural log of a, which will be the natural log of 4, times du, which will be 1. Okay, now I'm ready to use the product rule, so I'll get y prime equals f prime times g, so I'll get 4x cubed times 4 to the x plus f times g prime, x to the 4th times 4 to the x times the natural log of 4. Okay, and then from here we can see what we can factor out. I notice I can factor out 4 to the x, because they both have a 4 to the x, and then they both can factor out an x cubed. So if I do that, if I get rid of the 4 to the x and the x cubed, I just have 4 left on the first part. And then on the second part, if I got rid of the 4 to the x and an x cubed, I'll still have an x left and the natural log of 4. Okay, number 13, find y prime if y equals log base 3 of x cubed over e to the x. Right, on this one, I'm actually going to separate my problem first. So I'm going to make this log base 3 of x cubed minus log base 3 of e to the x. All right, and now from here, I'm going to use the formula of y equals log au. My y prime will equal du over natural log a times u. So that's what I'm going to do for this one. And then from here, so I've got y prime equals, on this one, this would be my u, so I get du. I'll get 3x squared over natural log of a, which would be natural log of 3, times u, which is x cubed, and then minus the second one, I'll have du. The derivative of e to the x is just e to the x still, and then ln 3 once again, and then u. So in this one, you'll notice we can kind of do lots of canceling here. When I simplify this, x squared over x cubed will just become x on the bottom, so I'll have 3 over x natural log 3, and then minus, on this one, the e to the x is canceled, I get 1 over natural log 3, and then I actually can go one step farther, because I notice that they both have a natural log 3 on the bottom, so I can factor out a 1 over natural log 3, and if I do that, I'm left with 3 over x minus 1. Okay, problem 14, find the integral of x to the 5th times 7x to the 6th dx. All right, on this specific problem, I have an a to the u, and I know the integral of a to the u du is equal to a to the u over natural log of a. So that's the formula that I'm going to use, but I do need to do a u substitution first. So u will equal x to the 6th, which means du will equal 6x to the 5th. dx, I notice that I have x to the 5th, I'm just missing the 6th. So on the outside I'll do a 1/6. So now I have 1/6, the integral of, everything turned into du except for I still have 7 to the u. And so using that formula, my answer is going to be 7 to the u over the natural log of a, and a in this case is 7. So replacing, and I'm just going to kind of simplify this a little bit. On the top I'll have 7 to the u, so I'll have 7x to the x to the 6th over 6 natural log 7, and then plus c. Problem 15. Find the particular solution of x cosine x squared over y equals dy dx that satisfies the condition y of pi over 2 equals 3. All right, I know the first step in solving a differential equation is to cross multiply, so that's exactly what I'm going to do. I'm going to get y dy equals x cosine x squared dx. Now I want to make sure I have the same variables on the same sides, and I do. So as soon as that's ready, I'm going to go ahead and take the integral. On the left side, the integral of y is just going to be 1/2 y squared. And then on the right side, I notice that I am going to have to do a u substitution. I'm going to let u equal x squared, and then du will equal 2x dx. I have the x, I'm just missing the 2, so I'll put a 1/2 on the outside. So this leaves me with 1/2 integral cosine u du, and I know the integral of cosine is sine. It's not negative sine, it's just sine, so 1/2 sine of u, which is x squared plus c. Okay, now I'm going to be solving this for y. So the first thing that I'll do is multiply everything by 2. So I'm going to get y squared equals sine of x squared plus 2 times c is still just a constant. And then from here, I actually could solve this for y. I'm not going to square root it quite yet because I'm going to find my c first. I'm going to use this initial condition right here. So I'm going to have 3 squared equals sine of pi over 2 squared plus c. So I'm going to have 9 equals, the sine of pi over 2 squared would just be the sine of pi squared over 4 plus c. So c is going to equal 9 minus the sine of pi squared over 4, since we don't know what the sine of pi squared over 4 is, I'm guessing. So then I've got y squared equals sine of x squared plus 9 minus sine of pi squared over 4. And then to get the y by itself, we'll just square root both sides. And when we square root both sides, we are going to put the plus or the minus. And so I'll have this, and then I'm going to go one more step, because I noticed when we plug the y in, we got a positive answer, so we're going to ignore the negative part of that solution, and it will just be the positive square root.